Thank you. At events like this, we tend to talk a lot about architecture. So what I want to do is talk about architects, because those are the people who are doing, or at least supposed to be doing, architecture. So who here is architect by title? Like, who has architect on the business card? Okay, not so many. Who thinks they're doing architecture work but don't have the title on their business card? Very good. Well, I think should be many. Who has the title but doesn't think they're actually doing architecture? Also happens. I have seen this quite a bit. So what I have learned is that being an architect isn't about the title or what's on your business card. It's really a way of thinking, like a state of mind. And that's what I want to talk about a little bit today. So when I say architect, I mean all of you, regardless on what's on the card, because what we've seen is many folks do architecture work without necessarily having the title, and that really also doesn't matter. So the next thing is like, oh, how do you know you're an architect, right? If you can't rely on the business card, what do you need to be doing in order to call yourself an architect? And there's a lot of opinions about this, and a lot of them go towards, oh, the architects should be the ones making all the decisions, right? I'm always careful there, right? Because why would one person want to make all the decisions, right? How can this one person be smarter than all the other people together, so they should be making all the decisions? That doesn't sound so great, right? So my view of what an architect should do is, you shouldn't try to be the smartest person and make all the decisions. Your job as an architect is to make everybody else a little bit smarter. So you're a booster, an amplifier for the collective IQ of development team. So help them make better decisions, understand problems better, have more like decision discipline, maybe better documentation, those kind of things. So you're not the one who's supposed to be sitting up there sort of telling people what to do, but help people come to better decisions themselves about what they're actually going to do. And the ways you can do that, I have 7 sort of ways here that I think you can be that kind of architect, where you can be the person increasing or raising, boosting the collective IQ and making everybody else a little bit smarter. So let's go through this. Helps the clicker. The first thing I realize is when people talk about who is the most valuable architect? This is another question that comes a lot, right? There's many different flavors of architects, right? There's enterprise architects and data architects and infrastructure architects, security architects, cloud architects, right? We have many flavors of these. Now, who is the most important, right? And it's a bit of an odd question, but people will sometimes say, oh, chief architect, right? I used to have a title of chief architect. People would say, oh, that must be very important. On the other hand, you could say, well, if all the chief architect does is like draw pictures and sit in the ivory tower and it has a little impact on reality, maybe that isn't so valuable. Maybe the people who are very hands-on, working in the engine room, are more valuable. But you can make the counter argument, if the work the folks do hands-on doesn't contribute to the success of the organization, then that is also not valuable. So what I find is the value of an architect is not tied to sort of where in this level or where in this hierarchy they sit. The value of an architect is much more related to how many different levels you can cover. If you're only sitting at the top looking out the window, that's not that great. And if you're only in the basement doing random things, also not so useful. If you can make sure that these things are actually related to each other, that's where the high value of an architect comes from. And again, that's independent of the title, right? The person doing this might be called a chief architect, enterprise architect, anything else architect. The title is somewhat secondary. It's the way you think about your role and what you accomplish in the organization by connecting these different layers. Why is that so important that we connect these layers? Well, organizations are structured in many different layers. That's why I like to use the metaphor of the high riser, right? There's sort of top management at the top. And what happens when you have too many layers, management will live in a happy illusion. They heard somehow you're using blockchain and Gen AI, so they assume everything in IT is going really, really great. But they don't really go and look because they don't understand so much. And vice versa, the developers know that management doesn't understand so much, so they do whatever they like. They enjoy their freedom because nobody knows anyhow. How is this possible? Well, this is possible because we have a loosely coupled architecture. There's an isolation layer here in between, built out of middle management, which makes sure that the two parties never actually talk to each other. And that way, they are respectively happy, but it's not a good way to run an organization. So the separation of concerns, right? There's many different things an organization needs to do. That has some advantages, but if this is too isolated, that is not a good thing. So architects overcoming this separation is a very, very useful function. And because we have many architects by mind and by heart in the audience, to understand this, we can use an architect model. We like models, we like patterns. So this is a pattern, it's called layering. We use this all the time in our systems. Why do we like layering, right? When we build something, we like to structure this and layer this. Well, why do we do this? Because it has some really nice properties. One layer does one thing. You separate the concerns, you have clean dependencies between those, nice interfaces. You can swap a layer out easily and replace it with something else because you have clean dependencies. We call this replaceability. So layering affords you many nice things. Architecture is a business of trade-offs, so if something is blank on the right-hand side, that means there are also some considerations or concerns. There's some things that layering doesn't do so well. So overhead, right? If the layers, I would say, if the layers talk to each other all with like, let's say XML for argument's sake, right? Your system might be spending more time parsing XML and garbage collecting than actually doing work. And if you make things super, super, super fine-grained, you also have latency issues, right? By the time your requests go through all these layers, this takes a long time. Also, if you have too many layers, you're not sure what to put in which layers, so you have like your own complexity that this brings. And the last one, I'm sure many of you guys have seen, let's say you build a very nice sort of layered system that has a front end, a back end for front end, then it has an API layer, a business logic layer, an object relational mapping layer, and a persistent layer. And you want to add a field to the GUI. What happens? Well, you add the field to the UI layer, the backend for front-end layer, the API layer, the business logic layer, the ORM layer, perhaps, and to the database schema. We call that change propagation. Not that great. So as architects, though, we think deeper. So when we look at this, we notice a couple of things. The first thing we notice here, the things I just mentioned, they apply both to technical systems just as much as to organizational systems. None of these things really say this is a front end or a back end. This can be different departments, right? If something has to go through 10 departments and be translated every time, or you need to make a change, you have this in organizations just as much. Take replaceability. In organizations, that's called outsourcing or insourcing if you bring it the other way, right? So first thing you learn as an architect is you're much more qualified to be an organizational architect than you might have thought. Large organizations, complex organizations behave very similarly to complex technical systems. These patterns apply both to technical architecture and organizational architecture. And that's very useful because we have a lot of sessions here about socio-technical systems, right? Telling us that we cannot look at one or the other in isolation. So knowing that your architectural thinking already prepares you also to understand how organizations work is very, very helpful. So next time somebody asks like, oh, are you an organizational architect? You can also raise your hand because you do actually understand a lot about it. The second takeaway is the things on the left are slightly different from the things on the right. If you sort of squint very hard and sort of think about what category they're out of, you come to realize that the things on the left, they are more structural. You're talking about dependencies, separation of concerns, right? They're mostly sort of structural kind of things. The things on the right, they are more behavioral, dynamic, rate of change, latency, right? It has something to do with movement dynamic. So that gives you a hint that if things move slowly, the structural benefits that you have on your left outweigh the downsides on the right. You gain from the separation of concerns if things don't change very frequently. Once start things to change frequently, the things on the right-hand side start to outweigh the benefits. And this is exactly how we got to this point of the architect elevator. Things used to be slow moving in business environments. So these layers worked really well for these organizations. So now things are speeding up, a lot of uncertainty, a lot of movements. So now the layers work against them. And what you can't do is take 10 floors out of the skyscraper and expect to get a bungalow, right? You get a pile of rubble. You cannot do that. So that's why you write the architect elevator. So third lesson we take out of this is if you see something that isn't working well, right? If there's too many layers, too much coordination, it's easy to say, oh, this is stupid, this doesn't work, why do people do this, right? The reality is in many cases this used to work for them, and then something changed so that it doesn't work as well for them anymore. And understanding what that change is a big part of the architect mindset. In this case, the rate of change increased and it made all these layers less attractive. So overcoming these layers is a valuable maneuver, right? And that's what the architect elevator is all about. It's about connecting the different levels so that we don't have this loosely coupled architecture, but so that our technical decisions are clearly related to our business strategy and vice versa. It doesn't mean dumbing things down to management. I see that mistake made a lot, where people say, oh, management doesn't understand all our technical stuff, so let me make this easy for them. You're talking to some of the smartest people in the organization, right? They're obviously running the whole company and making important decisions, so dumbing things down for them doesn't seem like quite the right thing. So you want to explain your decisions and the trade-offs so that they can understand without confusing them, so get rid of the jargon, but also without dumbing it down. And that's highly valuable. So it's not about telling different stories at different levels, but it's about bringing the same story to the different level. Sometimes people feel that this connection isn't so immediate. They're like, what do I have to do with the business strategy? And I give a simple example. I used to work in a company where we discuss business strategy. So let's just say, for argument's sake, one of your strategy might be to enter other countries. You might be selling your product or service and offering that in different markets and different geographies. Another strategy might be you need a more diverse product line. You're trying to make more different products, more different things or services that you are selling. Or the third strategy is you stay in the same market in the same product, but you're trying to sell more of it, right? Like all very plausible. That's what business strategy looks like. Does that have an impact on your architecture? I would say so, right? If you go to different geographies, you need to be able to build up your systems in those geographies, most likely. So having high level of automations, maybe running in the cloud, right? It's going to be super handy to have local instances, either for regulatory purposes or latency purposes, right? If you're all over the world, being able to replicate your IT systems in all these places is super, super handy. If you expand your product lines and you sell many different things, integration becomes very important, right? One customer has 15 different products, right? How does this all work together? And if you're looking to grow existing products, it's largely a scaling question, right? How many customers can I get on this thing? So this connection is actually much more immediate than most people believe. And that's what the elevator is all about, to see those connections and understanding, the strategy has a clear impact on my technology decisions and vice versa, right? My technology decisions determine what business strategy we can successfully pursue. So that linkage is actually much, much tighter. That's why we want to get across these layers, right? That's why we want to do that. Give you an example, right? I said it's not about telling different stories at different levels, but it's about connecting the levels. So let's take an example that I use a lot. So let's say you're all geared up about the cool things you're doing in the engine room, right? You have like high levels of automation, this runs in the cloud, you have like Terraform or other things, right? Cool stuff so you can deploy very frequently, you have high velocity, many different deploys, and you've done a great job at having observability and transparency, getting feedback, right? You're like, we're running a super duper IT shop. You go talk to the CIO. CIO says, oh, that's really cute, but look, this is what my boss tells me. It's like, don't get me in the newspaper or fired, right? Like security, nobody wants to have any issues there. Nobody pays for IT that's not running. So it's all about availability, and hey, if you can spend less money, right, always better. Now the architect elevator job is to forge this connection, to show how the things on the left actually give you the things on the right. It's not about telling different stories. So how do you get security, right? The most obvious exploits are you run an old version of something with known exploits. Well, if you do this all by hand, right, chances are you're not going to do this very well. So automation and doing this quickly and having detection of anomalies is actually a huge contributor to security. How do you get high availability at low cost? Through automation and rapid detection, load changes, automatic provisioning, deprovisioning, right? That's how you scale up and scale down. You have a highly available system, and you do that at lower cost than, let's say, traditional sort of warm standby servers, which double your cost for 1% availability increase, right? So like N+1 scale-out architectures, all the kind of stuff that we have. So once again, you realize that it's not about telling different people what they like to hear, but telling them why the things at this level are actually the ingredients to achieve what matters at the other level. This is riding the elevator in action. One of the great ways you can do this is using metaphors, and you will see this a lot through this talk. By using metaphors, you invite your audience into your thought process. Because let's be honest, right? You go to management and say, yada, yada, we need like, managed Kubernetes clusters, Helm charts, this and that, CNCF landscape up and down, right? Basically, and okay, give me $2 million to do this and 20 headcount, right? That's how these conversations go. You make your great pitch of all the tech you need, and then of course you ask for some money. What they're really hearing from you is, trust me, right? Because they have no idea what you're saying, and they might trust you, right, and give you the money, but somehow, that is not the most useful conversation to have, right? If you use all this jargon and all these low-level things, basically they're hearing, trust me. So by using a metaphor, you can invite them into the thought process. Because again, you're talking to the smartest people in the organization, so excluding them from your thought process is a resource underutilization of your organization, right? You have smart people there whose brain you cannot use because you're confusing them with jargon, so they don't participate in your decisions, and that is not good for the organization. That's where this misalignment comes from. And to make it worse, some technical people do this on purpose, right? Because they don't want the other people to sort of meddle in their decisions, right? And as we'll see later, that is actually a very bad thing to do, because it leads to local optimization, and it leads to disconnect between the different layers. So metaphors are a very powerful way to make sure your audience becomes part of your thought process and your decision process, so everybody gets on the same page, and you're not essentially saying, trust me. They actually understand the decision trade-offs that you're making, and you will get buy-in from them. You will get actual support more than just trust me. Second one, a good way to do this is pictures. We like to make fun of architects. Architects are the one drawing pictures, right? And I find drawing pictures to be a very useful thing for architects to do, but not the kind of pictures that we commonly see. So if you go in some search engine and you type IT architecture diagram, you see things like this. And in the previous session, actually, Adam was like showing things like this, right? This is kind of what your system looks like, but people don't think about it this way, right? People have a mental model because the real system is too complex. So people will have a mental model that fits in their head to think about this. So for architects, it's much more useful to draw something that sets a shared mental model as opposed to trying to draw reality. Because this is not ultimately useful for coordination or for making decisions. This is kind of like, oh, now I see all the pieces, but what do I do with that? So architects should draw, but they shouldn't try to draw reality. They shouldn't draw the blueprints. They should draw something that represents the mental model. And analogies with real-world architects are always a little tricky, right? Software is not like making buildings, but I think in this case it holds because famous architects, building architects, don't draw the blueprints either. They sketch, right? So this is Frank Gehry sketched a building. And the danger of the sketches is that your first reaction is, oh, I could have drawn that. And the short answer is, no, you could not have, because there's a lot more behind these sketches than you might seem. There's the purpose of the building is in here, the site, the context of the building, just like in our architectures. There's many things baked in here. And the key thing the architect has done is abstracted the essence from the noise. They made an abstraction. And the simpler these sketches look, the better the abstraction that they made. So the more useful it is for us because it sets a shared mental model. And if you think like, oh, does this really have anything to do with what people build? The short answer is yes. If my Photoshop skills were a little bit better, I can probably get this fully aligned. This is the Guggenheim Museum in Bilbao, Spain. It sits by the waterfront, so it's very horizontal. It needs some big buildings for the exhibitions, right? This serves an actual purpose. It's not like artwork on the wall. This is architecture. It involves context, constraints, key decisions. So as architects, we learn that drawing pictures is good, but don't draw the blueprints, draw something that represents a mental model, something that abstracts away and makes a statement, something that eliminates a lot of the noise. Next maneuver, to make everybody else smarter, right? We're still in the business of making everybody else smarter. We want to be the IQ booster for the team. One maneuver I find myself doing a lot, or one situation I find myself in a lot, is the following. Two people debating something, but they each look at the problem from a different perspective. Just like in this picture. One person looks at this from the front and says, well, this is obviously a circle. This is as round as it gets. And the other person looking at it from another side and said, well, I have no idea what you're talking about, but this thing is a rectangle because it's as rectangular as it gets. And they will never get anywhere. Right? They will debate until the cows come home. I always say, if this happens at the pub, it's somewhat entertaining. If this happens at your workplace, it's not entertaining, right? You're not getting anywhere. And people believe they must choose A or B. Are we going to do circle? Are we going to do rectangle? Right? And debate and pitch and argue. And as architect, you come in and it's like, look, people, you're actually looking at the same thing. This is 3 dimensions. Give you an example that I'm sure you guys know a lot. Is like somebody says, oh, we need to speed up delivery, right? We need to get this done faster. The other person says, oh, we cannot compromise quality. We need to have time for testing. And then it goes back and forth. Speed up, testing, speed, quality, time for testing, right? Compress the schedule. They will go at this forever. And in this case, as an architect, it's an obvious example. You have the 3rd dimension. You have things like, how about automating more of the testing? How about shifting some of this left, right? You have other mechanisms in mind which increase the solution space. That's the key maneuver here, right? When people see the problem space and the solution space is very narrow, oh, it must be this or that, they will argue forever and they will never be happy. Because either they have crappy quality or they're behind schedule. Like you cannot find a solution. So as an architect, if you see more dimensions, you make people smarter, right? You give them more things to think about. You give them more choices. And that is immensely powerful. You're not telling them what to do, but you're sort of expanding their horizons on what the choices are that they can make. And that is very nice because they get to make the choice, because who are you to tell them, right? This is their schedule and their quality. Like, I don't know what they want to do, but I can give them more options. I can give them more dimensions along which to decide. So ultimately, they come to a better decision for themselves as opposed to me making a decision for them. And that is, this making everybody else smarter, amplifying everybody's IQ a little bit. Give you an example. So I work for cloud provider, I work for AWS. So one topic we talk about a lot is lock-in switching costs, right? I work on serverless engineering, step functions, event bridge, all the cool stuff. And then people say, ooh, I want to use all your cloud services. This is really cool. Serverless, fantastic. Sorry? Oh, my slides are gone. Well, let me talk. The slides are secondary. Listen to the speaker. We'll get those up. So lock-in, right? So the argument that comes, or the question comes, oh, I get your story, right? It's like, oh yes, I want to have fully managed services, loosely coupled, event-driven, right? This whole serverless, right? That's fantastic. I totally get you. But what if I need to go somewhere else, right? Is this gonna make that worse? And again, if you see this as one dimension, there's no happy place, right? Because either you're not getting to use the modern cloud tech that you would like to, or sort of you feel like, I'm kind of a little bit held captive here. So how can you see more dimensions? Well, this works in many different ways. The one way is you can see more dimensions. There might be the cost of switching, right? If you need to go somewhere else, that's not free, right? So you should think about that. But what is also the benefit you're getting, right? Maybe I have a more scalable architecture. Maybe I'm more efficient, cost efficient. Maybe I can deploy faster because I have smaller functions, right? Many things that I can do. So suddenly you have two dimensions and you can have more intelligent discussion. Is it okay to have slightly higher switching costs if I get utility against it? And again, I'm not saying telling you what to do, but you can have a more nuanced discussion because now you're not just discussing the switching cost, but also the benefit. So classic maneuver, make one dimension into multiple. But even sticking with this example, I wrote about this many years ago, you can do this repeatedly. The switching cost, the cost that you have to move something from A to B, also has many dimensions. Like switching the vendor is just one of many switching cost dimensions. Switching a product, even an open source product, even your own product has switching cost. Upgrading versions has switching cost. I often joke about at AWS for EKS, for managed Kubernetes, because I think last year we offered extended version support, right? So we have older Kubernetes versions that we support on our managed Kubernetes. And I always joke that this is my least favorite feature. Why is it my least favorite feature? Because obviously everybody should be on the latest version all the time, right? Isn't this, as an architect, what you would like? So why do we need to offer older versions? The answer is very easy. Version upgrades have a switching cost. People are busy with other things. Maybe they don't have full testing. Maybe they don't have another environment, right? They have many reasons they don't version upgrade. That is lock-in. They locked into one version of an open source project, because otherwise they'll be on 117 or 120, right? They'll be on another version. So this has many dimensions. And again, you understand, this thinking isn't just limited to sort of cloud providers and vendors. This is also related to anything, whether it's open source or architectures or even version upgrades. There's a third dimension. Let's just stick with the switching cost for a second. There's even a third dimension, which is maybe the switching cost isn't actually only related to the services I use, because that's a discussion we have a lot, but maybe it's also related to my own velocity. If I'm a well-oiled software delivery machine, I have automated testing, I can deploy easily, my teams function smoothly. If I run a lean ship and high velocity, maybe switching vendors is actually much easier for me than it is for other people. And I've seen this clearly. I know out of history, there was some days where JDK 1.6 had like some known security issues and it was no longer maintained. And large enterprises were like, oh my God, we need to go from like JDK 1.6 to 1.8. And they spent like millions of euros and years on giant upgrade programs. Was that like Java locking them in? It was no, it was they just not used to dealing with change. Like a startup company, like a small company, is probably on 1.8 already and they didn't even notice. So there's another dimension to this, like your own velocity has a lot to do with cost of switching. So these are all examples of thinking in more dimensions, one of the most powerful Mudurugas. One more example to this. Standardization and innovation agility. When I joined a large insurance company, I joined as enterprise architect. I didn't really know what that means, but it sounded good. And I soon found out that part of my job was to set standards, right? Like standard kind of list of common standards. And what I also didn't know, that quickly made me the most hated person in the organization, right? Because you're the one who tells people like, oh, I want to use this database. You're like, no, 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 you cannot use this one. You need to use that one because it's the standard. And then you argue back and forth. And they said, oh, but then cannot do what I want to build because I cannot use the database, right? We've all been there, right? One-dimensional thinking. And again, there's no happy place on this, right? You can argue forever. You know, the people think, oh, if you're more standardized, you get better economies of scale, less complexity, maybe skills transportability, but I kill innovation, right? I cannot be fast and agile, and you'll never be happy, right? No matter where you are. So same maneuver here. Platforms are the thing, we'll have a talk later about this. Platforms are the thing that harmonize and drive innovation. It's a subtitle of my book, right? Innovation through harmonization. We used to think of this as a conflict, left or right, and now we realize, oh, one actually drives the other. So luckily there's many examples of this, right? We talked about speed and quality, right? That is no longer opposites because with high level of automation, you can have both standardization, innovations, platforms do that, customization and low cost. AI and machine learning does this. You have an e-commerce store, every customer gets a totally tailored experience and it almost costs you nothing. Prototyping and scaling, serverless does this, and other modern technologies. You can build something quickly, but it will also scale. Yeah, and who would have thought that giving stuff away makes money? Look at all the open source IPOs, right? Like it's open and monetization. So this is one of my favorite lists, right? As we're making progress, we realize we can have our cake and eat it too because we think in more dimension. So very, very powerful architect maneuver that you can use all the time. So we talked about metaphors. So here's a metaphor for you. Oops, sorry, yeah. Options. So I come out of the financial services industry, so let's talk about options a little bit. And let's talk about actually this idea of innovation and harmonization, right? The key point we had just previously. So let's say I want to have some diversity, right? I want to allow people to code in these languages and other people want to code in those languages. And you can make all sorts of fun about languages on the left, on the right, but that's not the point right now. Let's just say you want to enable this diversity, right? Because it makes you innovate faster, agility, all these things. How do you get this to work? Well, as architects, we all know very easily, you get this to work by making common APIs, common protocol, common authentication schemes, common data formats, right? That's how we allow this. Zooming out a tiny bit, you know, turning on our architect brains, what's the maneuver that we did here? We harmonized something, right? We locked down the protocol. We make people use a common protocol, but in return, they get diversity, right? In return, they can use different language. Interesting maneuver, right? You know, innovation through harmonization. We harmonize some things, in return we get more flexibility. If there's something that we believe we can only do in TypeScript, now we can, but because we gave up some options. So this is options trading. We now have the option of using different programming languages by giving up the option of the protocol. So we're trading options for each other. Very interesting way to think about architecture. What do you lock down? And if you lock something down, you don't reduce choice, you actually increase choice. You gave people more choice because you locked something down. And that's a much happier way to think about the role of the standards team, because you're not the most hated person now. You're the person who enabled people to use different languages, right? And this is just a simple example that I'm sure everybody already knows to make the point. You can use this in many different cases. So, you know, lock some things, give up some options, but the main purpose is so that you get other options, that you get other diversity. The fact that this is valuable is easily understood by this equation. Everybody with me here, I hope. All jokes aside, I always say, listen people, when you go to management and you talk about your engine room stuff and jargon, to them it's exactly like what I'm doing to you now. Right? You're showing some like magical stuff, which to you is totally obvious, but to them is completely cryptic. Well, there's some Greek letters in here, so maybe you guys, you know, there's sigma, so maybe you have a slight advantage, right? But basically, this is completely obvious to them. You ask any financial services person, they're like, yeah, totally, I know what this is. But to most of us, this is like, what I was going to joke is Greek, but the joke doesn't work well here. It's incomprehensible. You know, stress not, right? This is, people got Nobel Prize economics for this, so, this stuff is a little bit complex, but basically, this is the Black-Scholes formula for options pricing. And this shows that having options is always valuable. Even the option to go to another cloud provider, because there might be a chance that you one day have to do that, so that has value. The option to use another programming language, the option to scale up and down. These are all options you want, and this shows that all these options have value, but in real life, things that have value also have a cost, right? Now, what's interesting in this formula, and I was talking about sigma here, that is actually the important part of this equation, because what this formula shows us, the higher the level of uncertainty, the more valuable the option. So let's stay with this, the option to add hardware easily, capacity, right? The cloud does that for you, for example, right? It makes it very easy. You need double the capacity, boom, you have it. When is this most valuable? Well, it's easily understood, right? This is most valuable if I have no idea what my capacity needs are, or that they change suddenly. If I build something for 5 users internally, and it's always 5 users, if one calls in sick, it's 4, whichever, right? Like if it's very constant, that option is not so valuable, right? If I build a mobile app, might have 1,000 users, I might have 100,000 the next day. If I'm successful, this option becomes highly valuable. So the more uncertainty I have, in financials they call this the volatility, right? So the more this thing is unpredictable and sort of not steady, the more valuable these options become. Is that sigma, the sigma square that is in there. So the thing we learn here, again, architect brain geared on. So if our business as architects is to sell options, to create options, and these options are more valuable the more uncertainty we have, that means in an uncertain world, we need more architecture, right? So it's good for architects because we live in a very uncertain world. And funnily, that very statement came from a business owner, like a person who reported to the CEO of a very large insurance company, not being a technologist at all. That statement came from him because I used this metaphor. And because I used the metaphor, I allowed him to think in this space because I translated my system into his domain. And then he could reason, oh, I like this options thing because uncertainty increases the value of the options. That seemed very natural to him because he knows all this stuff. And he say, we live in uncertain times, I should invest more in architecture. Right? That is sort of the dream conversation you want to have by using metaphors. You let the audience come to their own conclusion because they can reason with financial options because that's what they do, and they come to their own conclusion. If you work in a different domain, right, you use different metaphors. Second point, so we just concluded architecture is good with high levels of uncertainty. Right? That's where architecture thrives. If nothing ever changes, you don't need a lot of architecture, right? You get it to work somehow, right? Yeah, it runs forever kind of thing. We don't live in that world. There's another common approach that starts with A that also thrives on uncertainty. Agility, right? If we know everything, nothing changes, I don't need to be very agile. Write it down, build it, done. So we come to an interesting conclusion. Both agility and architecture thrive on uncertainty. If I have high levels of uncertainty, I want to be agile and I want to have a good architecture because it gives me these options. So next time somebody comes to you and says, dear architect, I find what you do really fantastic, but sorry, I'm agile, right? Don't need you. You have a very clever answer to that. Right? You say, oh, great, you're agile because you're surely dealing with high levels of uncertainty. Like, yeah, lots of uncertainty, right? It's like, you're like, me too. Right? So actually architecture and agile thrive in the same kind of environment. They're not opposites at all. They both thrive on uncertainty. And that's why we talk so much about agile. And that's why we talk so much about architecture. I like to use car metaphors. So I like, agile is the steering wheel and architecture is the engine or the gas pedal. One makes sure that you can keep moving and the other one makes sure you move in the right direction. One without the other, not so useful. Right, going straight line into the wall, maybe not clever, and turning the wheel if you're not moving also doesn't do anything. So there's another metaphor for you, right? Why agile and architecture go well together. I hinted a little bit at this zooming thing, right? Seeing things from different levels of abstraction, and that is another very important skill. So it's dimensions, but it's also zooming. Now our world is complex. So when we zoom, it's not like with a camera where sort of the same stuff a little bit smaller or a little bit bigger. We really see different things, right? When you zoom, it's like these Mandelbrot sets, like these fractal structures. If you zoom in and out of IT, usually you see a different world, right? And many frameworks, like I saw Simon Brown last night, like C4 framework, right? Many of these things are about seeing your architecture from different levels and zooming in, zooming out. And yes, the next level is not making the boxes bigger, right? The next level is showing different kind of boxes. So that's a great example of this kind of phenomenon. Zooming in and zooming out is very important. Why is that so important? The ability to zoom out helps you understand the system characteristics. So let's say you have a system made out of 4 very helpful components, A, B, C, and D, and they wire together like this. Well, they wire together like this, and you have another system that's wired together like that. Do you think these two systems have different characteristics? Well, I'm not going to put you on the spot here. The obvious answer is yes, they have totally different characteristics, right? What is the left-hand side? Layering, already learned, right? All the ups and downs and layering. Clean dependencies, replaceability, but long run times could be brittle. If B fails, the whole thing doesn't work anymore. What is the right-hand side? Exactly the opposite. Short path, resilience, right? If B is not there, A can still talk to C and D, right? But replacing something is becoming harder. So exactly the opposite characteristics. Would you know that by just looking A, B, and C, and D sort of in zoom in isolation? Well, no, you would never know that. So being able to zoom out and understanding sort of the gestalt, right, the overall structure of the system is very, very helpful because that's where the important characteristics come from. Interestingly, this is also where most of the problems come from. I could call this the all lights green, nothing working syndrome, right? Each component is running perfectly, unit tested, up and running, but in the end nothing works because the dependencies between them somehow not going the way that you would have liked. So zooming in and zooming out ending up being very important. So what we learn here, the important part about zooming in and zooming out is that optimizing locally is good and a natural thing to do. Let's talk about DevOps, right? Before, we all liked DevOps, but when we had Dev and Ops very separately, they optimized locally, right? Dev made sure they release software as quickly as possible because that's what they get rewarded for. That is called optimization. They're doing well at what they're supposed to do. And of course, they throw it over the wall and they don't care about operational things because that's somebody else's problem. What does Ops do? Well, Ops tries not to make ever changes because they learned that every time Dev pushes something, there's new problems coming with it. So each one optimized locally. But we all know that is not a good way of working. So DevOps is an example of zooming out and optimizing globally versus locally. Rather than each team doing the thing they're rewarded for best, we now have a global view and say, hey, both is important. Feedback cycles, right? Error budgets, get the rate of change calibrated with the error budget, like all these kind of considerations, those are one level zoom out, they're global optimization. And you can map that across many, many different things. So what we learn here, right, the takeaway is that the sum of local optima is rarely or never a global optimum. So as an architect, the ability to see the global optimum, value stream mapping is an example of this, right? Flow, a lot of people who talk about flow, making sure your optimization and your function contributes to the flow, that is the architect elevator is this, right? Because otherwise, what did we hear, right? Penthouse is happy because live in illusion. Engine room is happy because freedom. That is local optimization, right? So turning that into global optimization, that is the essence of writing the architect elevator. Also teaches you a little bit that making this change is not easy. Because in the local optimization, every team is respectively pretty happy because they found their local optimum, right? If you go in and say, no, this is about global optimum, you will get some resistance, right? I have a lot of talks about architects as change drivers, and this reminds us why you have some resistance, because in the end, you're making both parties unhappy. Right? You're taking management's illusions away and you're taking developers' freedom away. You kind of made both unhappy, but in the end, you make the organization more successful. So zooming out, very powerful maneuver, but also don't make the mistake to think these changes are easy to make because people like their local optima, but they're not a global optimum. Coming, I think, to the second last, models and decisions. So we talked about sketches, and that sketches are so important because they're models. The biggest enemy we have in all this is complexity. If we don't understand the systems we're working with, it's very hard to make decisions. Models are powerful. And in the previous talk, we talked about mental models, because models shape our thinking. So this is a graph I borrowed from Dave Farley many years ago. Right? There used to be a time where people thought, oh, the Earth must be in the center of the universe. Why? Because we're just more important than anybody else, right? Or whatever it was, right? You know, they're like, oh, obviously we're in the center. That's called the geocentric model. Well, it turns out, if you look at the sky and you believe in the center of everything, okay, the sun still works kind of okay, comes up in the east, goes down west, right? That is okay, but the other planets, they do pretty funny things, right? It's like, Now, you can now study in this model, it's like, oh, how can a planet of this size and weight make like these sharp turns, right? And you start breaking your brain about like trying to find explanations for it. And basically, you're using the wrong model. Like, everything seems horribly complicated. The right model, right? The sun is in the center, makes this much easier. And reality is ellipses, but that's fine. This is a model. It's not reality, and they're also a little bit bigger than we've drawn here, right? It's still a model, but the model helps you with your reasoning. You can talk about how quickly the planets move, right? You can make these kind of things. Talk about bringing change. Some people lost their heads about changing to a different model here, proposing that the model is different, right? That wasn't always popular, so keep that in mind. But models shape our thinking. They define our perceived solution space, right? They're basically the coordinate system in which we think, and if that coordinate system is a bit funky, we think in strange ways. So picking the right models and abstracting extremely useful. Coming back to our sketches, the purpose of the model is not to represent reality. The purpose of the model is to help you make better decisions. IQ booster, right? The model is there to make you smarter, to help you make better decisions, right? And that's why all models are wrong. Some are useful. Everybody knows that quote, but George Box was a clever guy. There's a footnote to it, and it says, the simple evocative models, those are the ones you want. These overly elaborate that look pretty fancy, they're not actually that useful because they're not abstracting enough. So good models abstract. Now the question is, what abstraction should they have? So this is a poor abstraction because this is trying to draw reality. So we want more abstraction. But the question is, which abstraction do you pick? So here's 4 abstractions of a model that we know, of a system that we know well. The system is called planet Earth. So which model is the most useful one? It's a trick question because the best model depends on the question you're looking to answer, right? We're not in the modern art museum here, right? We're not drawing abstract pictures. We're trying to be smarter, make better decisions, more informed decisions, get more people on board with our decisions, right? That's what we're trying to do. So a good model depends on the question you have, right? If you want to go on a hike, right, or build a ski resort or build your house outside the flood zone, right? Topographical map, super. You know, elections, political map, driving. This one is a population density. Some of us are in the business of building distribution centers. A very useful map, right? Transport map and population density map helps you decide where you have a fulfillment or distribution center. So as an architect, next time somebody says, please show me your architecture, what they mean is a model of your architecture. It's a valid question, a valid counter question to say, what question would you like to answer? Because that determines what model is most useful. There's not one model that answers all your questions. So knowing the question is necessary to give you a good model. So the key thing here is no tapestries, right? The tapestries, they're cute and nice, but they don't help you so much make better decisions. You want better abstractions. One counter argument I often get, people say, oh, we cannot model this because we don't know how many users we have, we don't know this, we don't know that. Funnily, models are more useful when you have high levels of uncertainty because it forces you to make assumptions. So if there's many things you don't know, the model is actually most helpful because it forces these kind of things. Let's stay with this cloud migration thingy, right? It's like, oh, we don't know. Well, is it like 1%, 10%, 5%, 100%, right? Pick a number, make an assumption, and then you can use a model to help you make a smart decision. So come to the very last one, right? So if dimensions and zooming wasn't enough, right? We also learned that the world of architecture is not binary. Our CPUs are, so we like to think in ones and zeros, but that's good for the processors, CPUs. The world of architects is not binary. So if you see an architect who tends to speak in, it's always this or always that, right? Everything must be in a container, or everything should be in the cloud, or nothing should be in the cloud, everything should be here. Java is the best language of all, right? Whichever one you pick, that's a sign of a not so great architect, right? Like architects understand the trade-offs, they understand there's a spectrum. We learned that spectrum has many different dimensions. So shades of gray in multiple dimensions on top of that. So you have a lot of solution space to maneuver in, and understanding that and picking the right spot in that space, that is the role of the architect, right? So these people who spit out buzzwords, products, or make these absolute statements, they tend to be, in my view, not the greatest architects. So hopefully I was able to convince you a little bit that architect, or being an architect, is fun, right? It's a very interesting thing, bends your brain a tiny bit, right? Dimensions and zooming and options and metaphors, but that's what makes it really fun. And it is super valuable because you connect these levels and you make everybody else smarter. Basically, you're amplifying everybody else's ability to make decisions. So if you like this kind of way of thinking, there's always not enough time to pack everything in one talk. There's books and stuff around it. One I want to highlight, Platform Strategy. We just launched. So Michele and Jean-Francois have a talk at 5:30, and we have the first ever printed hard copies of those, a few to give away. So make sure you join us there. Thank you so much.